we're going to be taking a look at a more advanced absolute value function for example 2. Let's read this together. It says determine a general formula for the absolute value of, the antiderivative of the absolute value of cosine of x. So not only is it an absolute value function, but it has a trig function inside. Furthermore, we're only going to be looking at the interval from 0 to 2 pi. That's because we looked at the last example. The antiderivative of an absolute value function is in pieces, and you can imagine cosine goes on forever, so we want to limit it to a certain domain, in this case 0 to 2 pi. We're going to do exactly the same steps as we did from the previous example. For step 1 is going to be the same. We want to figure out where our graph that's inside of the absolute value bar crosses the x-axis. This way we can figure out where it's negative and positive and flip the negative pieces up by multiplying them by -1. So where does cosine of x equal 0 on the interval 0 to 2 pi? This kind of just goes back to your unit circle and knowing where x is equal to 0 on the unit circle. First we have x equals 0, whenever x is equal to pi over 2, cosine is equal to 0. So there's one example. Again, kind of looking at the unit circle would be up here. And then the next one we can see, once we scroll down, is going to be at 3 pi over 2. So from 0 to 2 pi, these are going to be your two places where cosine is going to be equal to 0. And if we look at the graph of cosine, which I'm going to draw as well, let's go ahead and draw here. Cosine at pi over 2 and at 3 pi over 2 is going to be equal to 0. Now it equals 1 at 0. So if we go and sketch this, it's going to look something like this. Whoops, that's not an arrow. We're going to cross 0 at here and here. And so what you can see is what? You can see that it's negative down here. And we're going to have to take this piece and flip it up, right? We're going to have to flip it up in order to figure out its antiderivative. So keep that in mind, this visual, as we move through this example. Again, the reason why we're flipping it up, I want to explain this, is because it's the absolute value of cosine of x. So the absolute value of cosine of x would look normal right here, but right here we'd have to flip it up to turn it into absolute value. What does the absolute value of cosine of x look like? Well, if you flip every piece that's below up, it's just going to look like a bunch of humps like this. Same for sine. So this is why we're turning into a piecewise function, so we can take those negative pieces and flip them up. Step 2 is going to be the same as before. We're going to come up with a sign chart. Remember, you're plugging in the test value to the function without the absolute value sign. So in other words, just cosine of x. We already alluded to this before. From 0 to pi over 2, cosine is positive. It's above the x-axis. We can do that using this test value of pi over 4, which is between 0 and pi over 2. From pi over 2 to 3 pi over 2, it's going to be negative. If we plug in the test value of pi, which is between these two, we get -1. And the reason these test values work, again, is because this is the only places where cosine crosses the x-axis. Then from 3 pi over 2 to 2 pi, we plug in 7 pi over 4, we get positive back. Only negative from pi over 2 to 3 pi over 2, which again we just looked at. So we're going to have to take that little curve and make it go up. So step 3, we're going to break the absolute value function into piecewise functions. Remember to multiply the pieces of the function that are negative by -1. Keep the positive pieces positive. So if we break up the absolute value of cosine of x into 3 pieces, we're going to have positive cosine of x from 0 to pi over 2, negative cosine of x from pi over 2 to 3 pi over 2, and positive cosine of x from 3 pi over 2 to 2 pi. Now I do want to show you what this would look like again, so I'm going to draw it one more time. because it can get confusing. So basically, from 0 to pi over 2, it's going to be this hump. Now, because it would normally go down right here from pi over 2 to 3 pi over 2, we're going to take that same, I'm going to have to erase this first hump because it's not drawn very well. Let's just come down a little bit more than this. So, we're just going to have to take that hump that's below the x-axis and make it go back up like this. And that way, cosine of x, if you take the absolute value of it, it's always going to be positive. And so that's why we take this middle piece right here, this little blue piece that would normally be below the x-axis, and we put a -1 in front of it. That way it flips it. Remember, when you take any piece of a function and multiply by -1, it flips it over the x-axis. And again, that goes back to function transformations. So keep that in mind. That's why we're doing what we're doing here. Now, the other pieces are already above the x-axis, so we do not need to multiply them by -1. So absolute value of cosine of x is equal to these three pieces from 0 to 2 pi. Step 4 is to simplify this. Now, there's really no simplification to do because you're just multiplying that middle piece by -1, so we're going to move on to the next step. Now that we've broken them up into pieces, the antiderivative of absolute value of cosine of x will just be the antiderivative of each of these pieces. This is going to be simple. Antiderivative of cosine is sine. That means the antiderivative of negative cosine is negative sine. It's going to be sine as well for the third piece. So that's actually it. When we take the antiderivative of the absolute value of cosine of x, we get sine of x plus a, or plus c, or whatever constant, for your first interval from 0 to pi over 2. Antiderivative of the middle piece would be negative sine plus b, or plus any constant, from pi over 2 to 3 pi over 2. And finally, the antiderivative of the third piece, which was cosine again, goes back to sine of x plus c from 3 pi over 2 to 2 pi. I want to show you what this antiderivative ends up looking like. Again, the antiderivative of this is a piecewise function. If we graph it down here, we can see that, it definitely looks like and is a piecewise function. Now, you might be thinking, okay, well, how can the antiderivative of the absolute value of cosine of x, which is a bunch of humps, look so weird like this? Well, if you take the derivative or the slope of the tangent lines of this weird antiderivative function, which is this piecewise function, the slope of the tangent line at any given point can be found by taking the derivative of this. You are going to get absolute value of cosine of x back, which are these humps. For example, let's say we wanted to figure out the slope of the tangent line at pi over 4 of our antiderivative. Well, we look at our first piece here, which is this little chunk right here. The derivative of sine of x is cosine of x, and the slope of this line at pi over 4 would be whatever cosine of pi over 4 is, which is square root of 2 over 2, which is going to give us the y value of our absolute value of cosine of x would be square root of 2 over 2 at pi over 4. So it's a little complicated, but again, if you take the antiderivative of an absolute value function, you're going to get a piecewise function back. That's it for this example of antiderivatives of absolute value functions. If you have any other questions about it, let me know.